Alright, now let's look at question 9. An object with a positive charge is placed at P, okay, and a similar object with a negative charge is placed at Q. The diagram shows a number of lines along which the potential has a constant value. So, okay, so we have a positive charge at P, negative charge at Q, and all these lines, okay, represent a potential. The lines represent a potential with a constant value. So this anywhere along this line, any point along this line has a potential of positive 100. Anywhere along this line has a potential of positive 200, and so on. This is positive 0, and this is just 0, and so on and so forth. So our question is, which graph shows the variation with distance along PQ, just a straight line here, with the electric field? So in other words, we want to find a graph of the electric field against the distance. Okay, yeah, let me look at all the answers. Okay, electric field against distance, electric field, all the electric field against distance. So which gives me the correct graph of electric field against distance? Okay, now this is a similar concept as to, I think I mentioned this in question 2, question 4, and question 6, that if you look at your equations table, okay, so the question we must ask ourselves is, how is the electric field strength related to the potential and the distance, right? So if you look at your equations table, let me just make a little bit of room. Your equations table will give you this, that E is equals to delta V over D, correct? That means the difference in potential between 2 points and the distance between those 2 points will give me my electric field. And delta V can always be the same. If you notice, what's the difference between these 2 points, right? These 2 lines. This is 100, this is 0. So the delta V here will be 100, right? Not sure whether you can see, but delta V is equals to 100, right? Same for his 2 points, delta V is 100, delta V is 100. So we can assume that all the delta V's here are the same, right? Delta V between this point and this point is 100, this point and this point is 100. Between any 2 lines, okay, between any 2 adjacent lines, okay, the delta V is 100, right? So let's say we assume this to be constant. So what changes is then the D, right? And if you look closely, let's say, look at this positive 100 and negative 100, right? The distance, how far they are, very far apart compared to, let's say we look at negative 200 and negative 400, right? This distance is much smaller than this distance, right? Therefore, we can straight away say that the E field here, because they have a smaller distance, if your denominator is smaller, your E field must be greater, correct? If your denominator is smaller, your E field, your gradient must be bigger, right? So this point must have a higher E field than this point, right? E field must be higher than this one, low, and this one, same again. See, this distance is very big. This distance between positive 400 and positive 200, the distance is much smaller compared to these 2 distance. So these 2 must have a greater distance, the greater electric field, correct? And notice, let me make an important point here. The difference between 400 and 200, positive 400 and positive 200 is 200, right? Is positive 200. But the difference between negative 200 and negative 400 is the same, positive 200, okay? The difference between negative 200 minus away minus 400 is also, okay, negative 200 minus minus is positive, so negative 200 plus 400 is just 200. It's also a positive value, right? So your E field is still positive, okay? Between 2 negative potentials, you still can have a positive potential difference, okay? I say that again. Between 2 negative potentials, you still can have a positive delta V, okay? And if delta V is positive, distance is obviously positive, E field must be positive, right? So your E field is always positive, right? And I mean, as seen by all these graphs anyway, the E field is always positive, but I just wanted to make that clear. So you can see that this one, has a high E field and then it becomes lower because the distance increased, and then the E field becomes high again. So which graph looks like that? Obviously is A, right? A is from high to low to high. But from C is low to high to low, which is wrong. It's actually the inverse, right? Okay. D is just from low going all the way to high, and B is just from high going all the way to low. But what we want is high, low, high. Okay, so answer is A.